One of the things that we did not talk about when we looked at the graph of secant and cosecant is the domain and the range. When you look at the domain, you are looking at the x values that could possibly make this equation true. Now, looking at just the graph, you recognize that it goes from negative 180 to 720, but all numbers would work for secant and cosecant except for one problem, the asymptotes. Remember, anywhere the asymptotes are drawn, the x value can't be chosen. In other words, in this problem, we could not choose the x value of negative 90 degrees, positive 90, positive 270, positive 450, and so on. So we have to talk about what the domain can be. The domain of a secant function is x, such that x is not equal to one of the asymptotes. Well, where do the asymptotes exist? 90, 270, 450. Those are all multiples of 90. So we're going to say 90 times some number. The problem is 180 is a multiple of 90 also, and it doesn't have an asymptote. Neither does 360, neither does 540, and those are all multiples of 90 also. So when we look at this graph, and this is the graph of secant, when we look at the graph of secant, remember that it's only the multiples of 90 that are every other one. And the way we're going to explain that is we're going to say that k is an odd number. So we're only going to multiply 90 times 1, which is 90, 90 times 3, 270, 90 times 5, 450, or maybe the negatives, 90 times negative 1, negative 90, 90 times negative 3, negative 270, right there. So understand that when you are looking at the asymptotes, ask yourself, what are all those multiples of? What are all those asymptotes multiples of? And they're all multiples of 90, but if it's every other 90, we say k is odd. What's the range of this graph? Well, notice that the graph has a minimum right here at negative 1. There's my minimum. Here's my maximum, and that's dealing with cosine. That's a maximum minimum of cosine. But in this graph, they're actually flipped. In other words, we don't want every number in between negative 1 and 1. We want every number outside of negative 1 and 1. So how do we write that? Y is less than or equal to negative 1, or y is greater than or equal to positive 1. And whatever our minimum value and maximum value are of the graph, if there's been a translation, the range is affected accordingly. When we look at cosecant, when we look at the graph of cosecant, the same is true. In other words, we're going to be looking at this graph and asking ourselves, where is the domain? So domain is all real numbers, x, such that x is not equal to something. Well, x is not equal to 180, 360, 540, 720, everywhere the asymptotes are. Wait a minute though, what are those all multiples of? Those are multiples of 180, so we're going to say it's not equal to 180k. But in this case, 180 times 1, 180 times 2, 180 times 3, in other words, they're all allowed. So k is just any integer. It doesn't have to be an odd integer, it's just any integer whatsoever, positive or negative. And what's the range? Same concept. We draw our maximum of sine, we draw our minimum of sine, and it's everything outside of those values. So y is less than or equal to negative 1, or y is greater than or equal to positive 1. Let's do one more example of cosecant, talking about the domain and range as well. So cosecant is the reciprocal of sine. So when I start my graph, I'm going to have my midline is at 2, sinusoidal axis is at 2. The amplitude is 3, so my maximum would be at 5, and my minimum would be right here at negative 1. I know that there will be 4 tick marks, only the period has changed. So we're going to take this, we're going to do this in radians. It said use radians. So we're going to do 2 pi divided by 1/4. We multiply the denominator and numerator by 4 to get rid of that. And we get 8 pi. So my last tick mark is worth 8 pi. My quarter period is going to be 2 pi. So every single one of these is 2 pi, then 4 pi, then 6 pi, and then 8 pi. Now, I'm going to ghost in the sine. So here's my sine curve. I'm just ghosting it in. It's not really there. Okay. And everywhere it crosses the midline, I'm going to draw an asymptote. So here's my asymptotes right here, and right here. There's all my asymptotes. Where do those exist? The asymptote didn't happen at 2 pi, it happened at 4 pi and 8 pi. So the domain, x cannot equal multiples of 4 pi, so 4 pi k. And then ask yourself, that's 1 times 4 pi, 2 times 4 pi, that's every single one. So we don't have to say k is odd in this case, it's every multiple of 4 pi. And what's the range going to be? Well, our graph for this function is going to be up here. Here is the cosecant graph. Well, when we look at that, it's everything below -1, so y is less than or equal to -1, and everything above 5, so y is greater than or equal to 5. We now know the shape, we know the period length, we know the domain, and the range. Good luck with your homework.